In this video, we will be looking at different kinds of mathematics and figuring out which ones need to be converted into an accessible format. I will be spot reading with both JAWS 2025 and NVDA screen readers. You can do the same by searching online with the keywords download JAWS and download NVDA. Note that JAWS will only run for 40 minutes after you restart your computer unless you have a license for it. I will also show processes for using MathType and Mathpix programs to convert numbers and equations to a more accessible format. Both of these are paid applications. Skills you'll learn in this video: how to spot read with JAWS and NVDA, how to decide what elements of a document to convert to a MathType object, shortcut keystrokes associated with converting mathematics in Word, how to convert a section of basic text to office equations, or OMML format, and then mass convert to MathType, basic editing in MathType, how to use the Mathpix snipping tool, how to use the Mathpix online PDF tool, and a bonus. Let's start by figuring out which of these numbers we need to put into a MathType equation and which we should leave in a text format. The 69- and 70- are not really mathematical expressions, so we should leave those alone. It might even have the disadvantage of pronouncing the dashes as minus or negative signs. Next, the 57.3% might need to be converted if it had the percentage sign, but because the word percent is spelled out, it should read just fine with a screen reader. Let's test that to be sure.
JAWS Demo Doc Chapter 5 Regression for whom we predict turnout rates of approximately 57.3%.
Yeah, basic numbers like 57.3 should not need converted. The next set of numbers is a different story though. When I read through it with JAWS, most of it is understandable, but the space characters are not ideal.
Left parent minus dot 1381 plus dot 0103 space marker 69 right parent space marker 100 right parent.
The dots are meant as multiplication symbols, but OCR has inserted a dot space character. Instead, they should be announced as dot operators or bullet operators. Also, if we read through the same equation with NVDA, you'll notice that it doesn't even mention the multiplication character.
Minus dot 1381 plus dot 010369, 100.
Both of these would be a big problem. So now we need to consider what kind of equation this should be converted into and the quickest way to do that. Let's first look at whether a Microsoft Office equation or OMML format would suffice. I can quickly convert this set of numbers and symbols to a Microsoft Office equation by highlighting it, holding down the Alt key, and pressing the equals key on the keyboard. Hopefully that will make the parentheses voiced and change the space characters to multiplication symbols. Let's first read through this converted equation with JAWS.
JAWS Demo Doc Chapter 5 for whom we predict math content left parent minus 1381 plus 0103 space marker 69 right parent space marker 100 right parent.
It does announce that the reader is entering math content, which is great, but it seems to have made some things worse. It now doesn't announce the decimal point before the numbers below 1. I think it's treating the decimal like a period because I hear it pausing before reading the number. How about with NVDA?
Cent. Minus dot 1381 plus dot 0103 bullet operator 69, bullet operator 100.
No, the parentheses are still omitted in the speech, but it now sees the multiplication symbols. I think we are going to have to use MathType to make this equation fully readable. We have a few ways to get the equation into MathType. We could highlight all of the numbers and symbols, copy them, open MathType, paste them, and close the MathType editor. This would leave us still needing to delete the original equation. That feels like a lot of steps to do for every equation. Alternatively, we could set up a macro that allows us to highlight the equation, press a keystroke, and the macro would cut the set of numbers and symbols and open the MathType editor. So really the macro would just be combining the keystrokes of Control-X to cut and Control-Alt-Q to open MathType. We would then press Control+V to paste and Alt-F4 to close the MathType editor. That's fairly streamlined, but there's an even quicker way. The MathType tab in Microsoft Word has a button called Convert Equations. This operation needs something to look for in the document to convert, but conveniently, we have already given it something to work with. I'll click the Convert Equations button and look through the settings. I'm going to uncheck all of the boxes except for OMML because I do want it to search for the Microsoft Office equation that we created. And I see below that I can convert equations throughout the entire document or in the current selection. I have found that this MathType conversion function is much quicker and more effective when you select the section of the document where you have Microsoft Office equations ready to be converted. Otherwise, it wastes time scanning the entire document text. It can also get hung up when you have 50 or more OMML equations in a document, so highlighting and converting is almost always the better way to use this feature. I'll escape out of the dialog box and highlight that section of text. Next, I'll click the Convert Equations button and make sure the box is checked for OMML. It looks like it automatically knew that I wanted to convert this section of text. I don't want it to prompt me before each conversion, and I do want these Office equations converted to MathType equations, so I will make sure that radio button is selected. Last, I can click the Convert button. Now when I read through it with JAWS, I should hear all of the relevant mathematical details.
Math content left parent negative 0.1381 plus 0.0103 space marker 69 right parent space marker 100 right parent ... page break.
JAWS still thinks the center dots are space markers. I'll double click the MathType object to open the MathType editor.
MathType
I'm going to delete the original multiplication symbols and replace them with MathType's smallest center dot character, and then use Alt F4 to close. This automatically saves our changes. Let's read through one more time with JAWS.
Alt F4. For whom we math content left parent negative 0.1381 plus 0.0103 dot operator 69 right parent dot operator 100 right parent ... page break.
Yep, sounding great. How about with NVDA?
Demo doc, chap, for whom we open paren, negative 0.1381 plus 0.0103 times 69, close paren, times 100, close paren page break.
So good. We also get the knock-on benefit of being able to convert these MathType equations to Nemeth or UEB Braille if needed inside Duxbury Braille Translator software. I see that MathType added an extra period after the equation, so
Line
I'll
feed.
delete it before I move
Page
on.
break. Dot.
Excellent. Let's look at the next section to determine what we need to do to those mathematics. Let's see if any of the numbers in this first sentence need to be converted to a MathType object. I'll read through with JAWS.
JAWS demo doc dash chap in the given line and dot plot the horizontal axis represents age that ranges from 18 to 88 in increments of 10 units and the vertical axis represents turnout that ranges from 0 to 0.6 in increments of 0.1 units.
Everything seems fine. However, as we saw previously, if either of these decimal numbers did not have the 0 and were in Microsoft Office equation format, JAWS would not voice the decimal. For that reason, we are going to make a pact to play it safe and put numbers less than 1 into MathType equations when we see them. We can leave the whole numbers alone though. Before we convert anything, let's check the next sentence.
The upward dash sloping regression line runs across left parent 18, negative 0.12 right parent, left parent 78, negative 0.5 right parent, and left parent 88, negative 0.6 right parent.
JAWS reads this in a way that would make sense, even if it might be better if JAWS announced the comma between numbers. Next, let's try NVDA.
Vertical axis. The upward sloping regression line runs across 18, negative 0.12, 78, negative 0.5, and 88, negative 0.6.
Yeah, NVDA makes this sound like a series of numbers rather than multiple coordinates. As we saw in the example on the previous page, it's going to be most effective to convert these numbers and coordinates to MathType equations, so we just need to determine the quickest way to get them into MathType. I think we're going to find MathType's convert equations function to be the best option. It's going to require that we get these numbers into a format that's ready to be converted though. For these coordinates, it should be as easy as changing these spelled out negatives to hyphens. Just for the practice, I'm going to highlight the line of text that I want to work on and press Ctrl-H to open Find and Replace. I'll type out negative space in the Find What field and a single hyphen in the Replace With field. I will replace all because I know I'm only working within the highlighted text. That's looking great. Next, I will start converting each of these numbers and coordinates to Microsoft Office equations because again, the MathType converter needs something to look for in the document. I'll highlight each and press Alt equals to prepare them. Note that you cannot use Ctrl-Z to undo this conversion to OMML format. Now that we have the appropriate numbers and symbols ready, I'm going to highlight those lines of text so that MathType only searches through this section of the document. Next, I can go to the MathType tab and click the Convert Equations button. It should remember my previous settings, but I just want to make sure that it is searching for OMML equations in the current section and is converting them to MathType OLE equations. After I click the Convert button, it confirms the number of equations that it converted. For whatever reason, MathType also inserts a period after each converted equation. I have asked the company if there's a fix for this and they told me there isn't. We can pretty quickly get rid of them though. We will leave the section highlighted and press Ctrl-H to open Find and Replace. I will put a period in the Find What box and leave the Replace With box blank. I can then start searching through the text for periods by pressing Alt plus F. I can press R for any periods that I want to replace with a deleted character, and I can press F to skip over any periods that I want to leave in the highlighted text. Beautiful. I'll read through one last time to confirm that this is the best reading experience.
Vertical axis represents turnout that ranges from 0 to math content 0.6 and increments of math content 0.1 units. The upward dash sloping regression line runs across math content left parent 18, negative 0.12 right parent, math content left parent 78, negative 0.5 right parent, and math content left parent 88, negative 0.6 right parent.
Demo. Vertical axis represents turnout that ranges from 0 to 0.6 in increments of 0.1 units. The upward sloping regression line runs across open paren 18, negative 0.12, close paren open paren 78, negative 0.5, close paren and open paren 88, negative 0.6, close paren.
Yes, I like that both screen readers are announcing all relevant details. Moving on. We have quite a bit more going on here. I can tell off the bat that we don't need to do anything to figure 5.1 because that's text rather than mathematics. Below that, we will definitely want to convert the equation, if only for the reason that it has the multiplication symbol that is probably going to call itself a space marker. Next, we have the alpha and beta characters. Let's read through those with both JAWS and NVDA.
Regression equation above. The regression parameters are alpha and beta left parent, the Greek letters alpha and beta right parent.
In our regression equation above, the regression parameters are alpha and beta, the Greek letters alpha and beta.
Because those have been inserted as Unicode characters, JAWS and NVDA are able to read them correctly. However, OCR sometimes misidentifies characters like that. In the next two lines of text, the alpha character has been identified as a lowercase a and beta as an uppercase B. I think I'll just copy and paste the appropriate characters from the first line to the lines below it.
Paste. Beta 1 of 5. Paste.
On the next line, those characters are included in simple equations. To be safe, I'm going to convert any kind of equation to MathType. The same could be said for variables, which we will see on the next page. I know I'm going to convert the final equation on this page, so I think I'm ready to decide the best way to do it all. We should be able to use roughly the same process as the last page. I'm going to highlight the first equation and press Alt equals to convert it to a Microsoft Office equation. However, because this has text as part of an equation, we need to do something extra. If we leave it as is, each letter will be read out as a variable. That's not ideal when these are actual words. We can easily change it by highlighting the words predicted crime, going to the Equation tab in Microsoft Word, and clicking the Text button. I'm actually going to leave temperature alone so that we can hear the difference after everything is converted. I'll quickly highlight and press Alt equals on the rest of the applicable numbers and symbols. On this last one, we do need to highlight predicted crime again and click the Text button under the Equation tab in Word. Before we click the Convert Equations button in the MathType tab, I will highlight this section of the document. Again, this speeds up the conversion process and keeps MathType focused on just the set of OMML equations. After I click the Convert button, we can read through the results.
JAWS demo doc dash chap. The graph of math content predicted crime equals alpha plus beta space marker TEMPERATURE.
Yeah, JAWS reads out each letter of the word temperature because it sees them as math characters. It's also calling the multiplication symbol a space character, but we can fix both by double-clicking on this MathType equation. I'm going to replace the space character with a dot operator and then highlight the word temperature. We could go to the Style menu and change this to text, but I like using the built-in keyboard shortcut of Control-Shift-E. I'll press Alt F4 to close the MathType editor, and now, when I read through with JAWS,
Point math content predicted crime equals alpha plus beta dot operator temperature.
Yeah, it's sounding much better. Last, I will change the space character to a dot operator character in MathType on the final equation on this page. We are looking good here, so we'll move on. Some of these things are looking a little broken. Let's start with the simple parts. The first line has alpha and beta characters, but we decided to leave those as Unicode rather than convert them to MathType objects. We also decided to convert any kind of equation to MathType, so we know that the numbers and symbols at the end of the first line will get converted. The second line includes the variable I, so we need to decide what to do with it. If we don't convert it, screen readers will pronounce it as the letter I, which is correct, but it doesn't convey that it's a special use of the letter I. We can do the same kind of quick convert using Alt plus equals and then use MathType's Convert Equation button, but let's finish looking through. The next paragraph contains a date and a simple number. Dates are not mathematics, so we will leave it alone. And 759 is a number that will read just fine without being converted. The equation at the end of the paragraph seems like it's using the variable I, but it's not clear exactly how it should be formatted. For this, we are going to need to look at the original text. I see the equations above on page 76. The equation beginning with the word error is nearly complete, but the equation below it is pretty far from the original. Let's talk through the options on the first equation. I could use our alt equals trick, mark the word as text, format the subscript i's, and let the convert equations option finish the job. This would probably take a couple minutes at the least, even though this is a fairly simple equation. I think we can do better. Instead, let's consider using a tool we haven't looked at yet called Mathpix. With Mathpix, I can drag a box around any kind of mathematics that are already correctly formatted. The tool will then use optical character recognition, or OCR, to create an accessible version of that math. I'm first going to zoom in on the error equation on page 76 so that I can get the highest resolution in my scan. Next, I'll drag a box around it. Mathpix automatically recreates the equation in its own program window. The program shows its confidence level at the bottom of the window, and I can see a few options for LaTeX code below the preview of the converted equation. All 4 options are the same equation, they just vary in the formatting of their code. If I wanted to edit any of those, I could click on the little pencil icon. However, if the equation in the preview window looks correct, there's a quicker way to insert the accessible equation than using LaTeX. I'm going to click the Copy MS Word button. I can then go to the line on my document where I want to insert the equation. It goes ahead and inserts the copied MathML as a MathType equation. Magic. Note, Microsoft Word might ask if you want to paste as a MathType object. You can say yes. We can do the same process for the larger equation below it and end up saving all of the time it would take us to figure out how to manually build this equation in MathType. Seconds rather than minutes. In fact, I think I'm just going to use Mathpix directly on the Word document to convert the simple equation at the beginning of this page and the variable I below it. Done. This last page looks the most complex, but we should be able to use what we've learned to knock it out pretty quickly. First, we need to decide what needs converted. The acronym OLS is not technically mathematics, but it will get pronounced as OLS by both JAWS and NVDA. I think we need to leave it alone because we can't correct every mispronunciation in the text. However, the alpha and beta values that have OLS as their exponents will need converted. In the next line, the number 0 is spelled out, which we can leave alone, and we have a couple of negative numbers after that. We know that the number less than 1 will need converted, but we have not seen a whole number that is negative yet. Let's just make a rule that all negative numbers need to be converted to MathType. This will ensure that screen readers pronounce the hyphen as a negative sign rather than saying dash or minus. The third line is pretty straightforward in that the equation will need converted to MathType, but there is a sticking point. If we highlight the equation and use our alt equals trick, the exponent 2 will become a regular numeral 2, making the 31 squared into 312. Instead, it's going to work better for us to highlight the equation, press Ctrl X to cut it, press Ctrl Alt Q to open MathType, and paste the equation. That way, it retains the exponent. I think that approach is going to work better for the alpha and beta values in the first line as well. Last, we need to figure out what's going on with this final equation. On page 85 of the textbook, I can see that it has lost some information in the OCR process. The subscripts and superscript have been changed to regular numbers. We could quickly use Mathpix to recreate this equation from the textbook in an accessible format, but it's a good opportunity to look at yet another approach. I'll switch over to a web browser where I have the online version of Mathpix pulled up. To get to this point, I have uploaded a PDF version of this chapter into Mathpix Online and let it perform OCR on the text and mathematics. I can hover my mouse beside the equation that I want to copy and look for the ellipsis icon. When I click it, I see that I can copy LaTeX code, MathML, ASCII math, or an image. As we did with the Mathpix desktop program, I'm going to copy the MathML. I can then navigate to the appropriate section of my document and paste directly as a MathType object. If we wanted to grab this 31 squared equation, we would just double-click on the line, highlight the LaTeX code, go to the spot in the document where we want to insert it, open MathType with Ctrl-Alt-Q, and paste the LaTeX code. You really can save a ton of time on documents that contain lots of equations by importing the entire chapter to the online version of Mathpix. The desktop version of Mathpix is also able to import PDFs, but I have not yet found a way to get MathML code from the resulting document. As a bonus, I wanted to show how to quickly recreate tables with Mathpix. A lot of times, OCR will break the formatting of tables as seen in the example above. I could painstakingly copy and paste all of these values to the correct cells of a new table, or I could use Mathpix. I'm going to zoom in on this section of the original page. Open Mathpix desktop software and drag a box around everything except for the table description above the table. That's looking pretty accurate. I can then press the Copy TSV or Tab Separated Values button. I'm going to go to the section of my document right after the mess and paste. Well, that doesn't look a whole lot better than the stuff above it. However, we have one last trick to try on it. I'll highlight what I just pasted, go to the Insert tab, click the Table dropdown, and choose Convert Text to Table. Now we're talking. I can then complete the cleanup by moving the numbers in parentheses to the lines above them, deleting the empty lines, and converting all appropriate numbers to MathType equations. Also, don't forget to make sure that the header rows and columns are marked. I think we did it. This has been a lot of information, but it will make a big difference for people who need accessible mathematics in Word documents.